In the previous series, we talked about architecture, where logic lives, how state flows, why rendering decisions matter. We broke down front-end from the inside. But real applications don't live in isolation. They talk to servers. They depend on networks. They deal with security. And that's where many front-end systems actually break. So in this new series, we're stepping into the hidden layer, the space between your UI and the server. This is concepts to real world. And today, we're starting with REST versus GraphQL. Your UI isn't slow because your framework is slow. It's slow because your data contract is wrong. Most front-end developers spend time optimizing rendering, component structure, change detection, memoization, but they rarely ask, is the API designed for my UI? Because performance doesn't start at the component layer, it starts at the network layer. Imagine you're building a dashboard. You need profile summary, recent activity, notifications, analytics snapshot. With a typical REST setup, that becomes one request for profile, one for activity, one for notifications, one for analytics. Even if those requests run in parallel, you still have multiple round trips, multiple loading states, fragmented error handling, complex coordination logic. Your UI becomes tightly coupled to endpoint structure. That's not a backend issue. That's a front-end architecture decision. Let's look at REST from a front-end perspective. REST is resource-based. Each endpoint represents a resource. It's predictable, it's simple, it works well with HTTP caching, it's CDN-friendly. But it introduces challenges. Overfetching. You ask for a user but receive 20 fields when your UI only needs 2. Underfetching. You need related data, but now you must make multiple calls to build one screen. And every extra request is latency, state management complexity, UI coordination overhead. Multiply that across dozens of screens. Now performance becomes a system problem. Now let's talk about GraphQL. GraphQL allows the front end to request exactly the fields it needs. Single endpoint, custom data shape per screen. From a front-end perspective, this feels powerful. No overfetching, no underfetching, often fewer requests per view. The UI defines the data shape, but power increases responsibility. Caching becomes more complex. CDN-level caching becomes harder. Deeply nested queries can become heavy, and without schema discipline, the system can degrade quickly. GraphQL gives front-end control, but control comes with architectural cost. So which one is better? That's the wrong question. The real question is, what kind of UI are you building? If you're building stable CRUD screens with strong caching requirements and predictable contracts, REST is perfectly fine. If you're building complex dashboards, dynamic interfaces, and multiple client platforms with constantly changing data needs, GraphQL can reduce friction. This is not about trend, it's about fit. Here's the senior front-end decision framework. Before choosing, ask, how many API calls does one screen require? How often does the UI data shape change? Do we rely heavily on HTTP or CDN caching? Do we have schema governance discipline? Is the front-end team ready to manage complex client caching? Because once you move complexity from the server to the client, you own it. The biggest mistake front-end developers make is blaming rendering performance when the real bottleneck is network round trips, overfetching, fragmented endpoints, poor contract design. Your UI performance starts at the data contract, not at the component layer. In the next episode, we'll talk about WebSockets and why most front-end teams don't actually need real time, but build it anyway. If you're building production-level front-end systems, this series is about thinking like a senior engineer.